All right, let's look at a problem that looks pretty innocent, but actually is way more complex than what you would think. Bell's about to ring, so I'm just going to wait. So let's look at a problem that's a little bit more complicated than what it actually looks. On the surface, this thing's pretty harmless. Tangent squared of 3x equals 3 from 0 to 2 pi. It seems fairly straightforward. I can just take the square root of this, and I can get tangent of 3x equals plus or minus the square root of 3. All right, well, that seems simple enough, right? Well, I can take the arctangent, and I can get 3x equals arctangent of plus or minus the square root of 3. So I'm actually going to have two different solutions to this. I'm going to have 3x equals, let's see, pi over 3 plus pi k. And then I'm going to have 3x equals negative pi over 3 plus pi k. And of course, k is an element of the integers. Okay, so these are my general solutions using the unit circle, using the domain restrictions of arctangent. Not terribly bad. But now I'm going to divide everything by 3. And I'm going to get x equals, because I want to know what x equals, not what 3x equals. I'm going to get x equals pi over 9 plus pi k over 3. And x equals, well, we're going to have a negative pi over 9 plus pi k over 3. Okay, so I already know I'm going to need a common denominator, so I'm going to make my life a little easier and set this up with a common denominator. And I'm going to say it's going to be pi plus 9 pi k over 9. Nope, this is a 3. And then this is going to be basically 3 pi k minus pi over 9. All right. So the reason why I did this is I already know I'm going to have to plug a bunch of numbers into this and I get a common denominator. So now I just have equations and I can just start putting in 0, 1, 2, 3, 4, 5 until I get up to, well, 2 pi is going to be 18 pi over 9. So I need to go all the way up to, but not past, 18 pi over 9. So we're just going to start doing this. If I plug 0 in here, I get pi plus 3 pi over 0 over 9. This gives me pi over 9. Now I'm going to do the same thing. I want to put 1 in here. Pi plus 3 pi times 1 over 9. Well, this is going to give me 4 pi over 9. I'm still good. I want to plug 2 in. Pi plus 3 pi times 2 over 9. 6, this gives me 7 pi over 9. I'm still good. All right, we're going to plug it in again. And I'm going to do pi. So I'm going to put a box around my formulas because I'm going to need more space. So pi plus 3 pi, I've got 2. So let's do 3 over 9. This gives me 10 pi over 9. Still good. Not over 18. So I'm going to keep going. I'm going to go to 4. Pi plus 3 pi times 4 over 9 is 12. This gives me 13 pi over 9. I'm still good. Let's go to 5. Pi plus 3 pi times 5 over 9. This gives me 15. 16 pi over 9. And I'm still good. I now know at this point if I had another 3 to that, I would be above my 18 pi. So far, I have 6 answers and I've only done this one. Now I need to do this one. And I'm going to do 3 pi times 0 minus pi over 9. This gives me negative pi over 9. This doesn't work. It's outside my domain restriction. 3 pi times 1 minus pi over 9. This gives me 3 pi minus pi, 2 pi over 9. That one works. Now we're off and rolling. 3 pi times 2 minus pi over 9. 6 gives me 5 pi over 9. 3 pi over 3. 3 pi times 3 minus pi over 9. This gives me 8 pi over 9. If you notice, these are all going up by increments of 3. 3 pi times 4 minus pi over 9. This gives me 12. Well, it's going to be 11 pi over 9. Still good because I'm below 18 pi over 9, so I'll keep going. 3 pi times 5 minus pi over 9. This gives me 14 pi over 9. Still going, and because I've noticed the pattern, they're all going up by 3, I know I can do it one more time. 3 pi times 6 minus pi over 9 gives me 17 pi over 9. All right, so that's pretty straightforward. I've got 12 answers, and I'm just going to write the 12 answers here. So in this case, my x equals, let's start, pi over 9, 4 pi over 9, 7 pi over 9, 10 pi over 9, 13 pi over 9, 16 pi over 9, start a new line, 2 pi over 9, remember we exclude this because this negative pi over 9 is not within my domain, 5 pi over 9, 8 pi over 9, 11 pi over 9, 14 pi over 9, and then 17 pi over 9. And there are all your answers. So this basic problem, tangent squared, 3x equals 3 between 0 and 2 pi, has a total of 12 answers. Gotta love it. Gotta love it. In this case, this is actually, I think, easier to do than u substitution, because you could have done u substitution and change your values between 0 and 6 pi and then get the exact same answers, but then you're still basically going through the same process over and over and over again. This way I created a formula that I can just keep plugging 0, 1, 2, 3, 4, 5, 6 in and spit out the answers. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.